Hello, everyone. Welcome. My name is George Habeck, Senior Manager at CT Global Solutions, a SaaS Trusted Gold Partner. Welcome to this exciting session. I'm very happy to be here to talk to you about a really critical business problem in this COVID intense industry world today. I've been using SaaS for over 30 years and have a lot of experience across many industries applying advanced analytics to help customers solve critical business problems. In this session, we're going to discuss a very important problem within the transportation logistics industry. The ultimate business question we're going to try to solve or answer is, what is the best subset of factors that drive shipping cost for the organization? Also, what's the optimal model to use to score a new prospect file with the predicted average cost? A variety of data elements, such as internal factors of package size, delivery day of the week, number of delivery days, etc. Also, external factors like weather and financial effects will also be utilized. Let's take a little peek at the data that we're going to use for the business problem. In this problem, we have basically 5 data streams that were analyzed and assessed. We had external financial information for the logistics organization, weather, obviously external information, package information like the size of the package and the number of items for each shipment, the different customers, where they are in terms of providing the shipping, and the products that they were shipping, the medium of how they were shipping it, and then information on the route, like the day of the week the package shipments were delivered, was it a weekend or was there holidays, and then the fuel, obviously, because that's very critical when you're in a truck delivering package shipments across the transportation network. So there's a very deep, comprehensive data flow that's injected into this business problem, which is what we're going to try to solve in the next few minutes. The reality is for this session is that we're going to discuss open source and how, because of the complexity of the transportation problem and the network, especially due to this COVID intense time and the world that we are in today, the idea would be to try to create the best possible set of statistical models. And we're going to do that by creating a bridge between open source, utilizing Python as a language, and a next generation state-of-the-art data mining solution for SaaS, visual data mining, and machine learning, or we can call it SaaS VDMML for short. So we're going to go through a step-by-step process of how to create this solution within the environment. The first piece is to install and configure a Python version, either 2.7x or 3.4 or later. And the very first element of this connection is that it should be installed in the compute server of where the SaaS VIA environment is. Python, in this instance, is really a software that you're loading. So when you're loading software, it should be loaded in the server or environment to where you're going to be performing the work. The next important piece is that there's an executable file that must be available in the system path. You would want to connect to Python, the language that we're going to be using, from SaaS VDMML, set the environment variable exactly in that path as it's shown, which is actually creating a file called SaaS COMP-SRV, and add this final export path line, which is really important to be able to create that connection to talk to Python. And then last but not least, you want to give sudo privileges to the Python packages, which basically gives full authorization to the users to be able to utilize Python. Next, we're going to discuss the Python models that are going to be utilized to solve this business problem. So we're going to develop the Python models via a Jupyter notebook. 4 machine learning models were developed in Python, and the sklearn library was the one utilized to execute the models. The four models are as follows: linear regression using an algorithm called ElasticNet, a neural network, a decision tree, and a random forest. So these are the four Python models that we're going to be utilizing. So if we think about Python, and now we're going to discuss SAS, the idea is to create that bridge and integrate Python models within the SAS VDMML environment. And we're going to just call that a pipeline to make it really easy. If you look at this graphic, this is a graphic of what SAS VDMML looks like and a picture of the pipeline. And if you notice these red boxes under the data, right, that's the data node that accesses all the data that I just mentioned on prior slides. And then you go to add a child node and you use the miscellaneous option. One of the options under there is open source code. And I highlighted an example to start. And we're going to be doing all of them in the Python, the four that I mentioned. But let's use the Python linear regression and show you how to create that bridge, and the others would be done accordingly. So to do the Python linear regression in the steps I just outlined, the next step would be to go to that open source code, and you see there in the box, Python linear regression, that's the name of that node. We're going to name it so it's very easy and visible for the user. Then I click on Open Code Editor. So we would go in there, and the options for the languages, there are a couple. Python is one and R is another. In this session, we're specifically focusing on creating the bridge for Python. To the right is actually when you invoke the Open Code Editor button, it would give you a white space, and you would go in and copy or paste or type, if you wish, the actual Python script to execute the linear regression model. So you would also do the other three models for Python in the exact same manner. Rename the node. Instead of Python linear regression, you would call the next one Python neural network, and then go take your neural network code or algorithm and paste it into that white space, and so on and so forth. So when we're done with that step, and as you see in the picture, we have the SAS VDMML nodes, linear regression, decision tree, the first two in purple. And then we have Python linear regression and Python decision tree for this first pipeline. If we run this pipeline, this will execute 4 data mining and machine learning models to try to pick a champion. And if you notice in the results, the SAS VDMML linear regression model was deemed a champion for the first pipeline. Now we're going to be executing 2 pipelines. And why do we need to do that? Well, we have to create the bridge and look at Python models as well as SAS VDMML models. So that means we're going to actually compare 8 machine learning models, right? 4 for Python, and similarly 4 for SAS VDMML. And that would get too messy to show on one pipeline. So it would be much more seamless and easy for the user to create 2 pipelines and break up the different models so it's easy to digest to the human eye and the user. So that is pipeline 1. Pipeline 2, we're going to look at the other set of models, a neural network for SAS, of course, and Python, and a random forest for Python and SAS as well. If we compare these 4 models, we notice that the Python random forest has now been deemed the champion for pipeline 2. And what are we using to assess it across the models? We're using something called the root average square error, which in layman's terms is simply a measure of noise. We want our models to have as little noise as possible, and we want those values to be very close to 0. So the winner is the one that has the lowest number. In our case here, Python Forest has been deemed the winner by the solution because it had the lowest root average square error. So we know the winner in each pipeline, right? pipeline 1 and pipeline 2. But the next question is, well, who's the ultimate grand champion across both pipelines? Which means out of the 8 models, who is the biggest final champion? And the answer is, lo and behold, the Python Random Forest has been deemed the overall champion across the 8 models. It had the lowest average square error. So if we look at that champion model, the business of the transportation industry might come in terms of the logistics company and say, remember my business question in the beginning? I specifically asked the question, what is driving the shipping cost across my network? That's something I've been really keeping myself up at night to try to answer to my business. Well, when I run the model, it gives me a list, a bar chart of the significant variables that really drive that business question. And if we look at that very first bar, the most important driver or variable to answer the question is the fuel expense. But doesn't that make sense? These trucks are driving all over the country. They're sending package shipments all over. You got to have fuel to operate the vehicle. And obviously, that's a big factor in what it costs to ship the packages. So that's okay. That's also telling us the models are working because a basic variable has come up in the model very strongly. But look at the other variables that have been deemed important as well. The product of what you're shipping, the subproduct, how you're shipping it. Is it overnight, commercial? Is it 2-day? Is it 3-day, express, things like that? The delivery time. How many days did it take to deliver the package shipments? Was it 1 day? Did it take 2 days, perhaps 3? If I'm going from Portland, Maine to the West Coast, let's say, of the US. What else do we have? We have the customer, the shipper name. Does that impact the shipping cost? Our model says it is up there in importance, maybe not as important, but it's still in the mix. And then we have the number of items in the package shipment. How many items was on the first shipment? Let's say, did I have 10 packages? Were there 15 or were there more? And then we have things like the volume, the size of the package shipment, right? It would make sense. The bigger the volume of the package shipments, the more expensive it would be. Hence, the heavier the truck would be, the higher the fuel cost. All of these components, the transportation company really needs to understand, and the combination of factors together to create actionable results for the organization. But why is this really important? I'll stress that again. Who cares? So what? Why do I need to know the best set of variables that's driving the shipping expense? Well, what's the ultimate goal of every company? To be profitable. So if I'm going to price out to my customers how much I should charge them to ship their packages, doesn't it make sense that I find out what it's costing me as the organization that's going to be the shipping company? Absolutely. So by doing this exercise, I get to truly find out in all of my network what is causing the shipping expense to go up and down. So once I get a good firm grasp of that, then I can find out what to price the package shipments to the different customers and do it in a manner where I can actually become profitable at the end of the day or quarter or year. What's the next step? After I develop this model, I want to then score a new file of all these different prospects to find out what is going to be the shipping expense for each package shipment. Now, I might not know that offhand. I want to predict it using the winning model. Well, in our case, our champion model, as we learned across the 8 models that we compared, was the Python Forest model. That was our winner. So the next logical step for deploying this out to the business field is to go get a file of different prospects. It could be 500,000 package shipments across different prospects. It could be 1 million. It doesn't matter what it is. Use the winning model, the Python, and score, essentially. Hence, I have the score node highlighted to assign the predicted average shipping expense from the model for each package shipment. That's very important because I'm going to end up pricing that to the customer. So I need to know what it's costing me first before I can decide how much I can price the customer to actually be profitable. When I do that, what do I get, right? This is the ultimate goal of deploying the machine learning model, is actionable results. Here's an example of that scored prospect file. So I have things like the state of this new prospect, where they're from, the sales segment, who the customer is, what's the product type? Was it a 3-day select? Was it a ground commercial, etc.? What's the subproduct? Was it a weekend delivery, do not stack, specific directional things for the delivery? How many items were in the package shipment? What's the volume, which is very synonymous to the weight? There's my fuel expense, which we all know was very, very high on the modeling list. How long did it take to deliver that package shipment? And lo and behold, this is the bread and butter of this. So let's say I go score this file, and I have the actual cost for me, the transportation company. So that's the shipping expense column. But when I scored it against the winning model, the Python Forest gives me the prediction of what that actual would have been. And that's critical because that's what I want to see, how accurate the model is. And if you notice, those are the two things I'm going to be comparing neck and neck. And just by glancing them through the naked eye, the numbers look fairly close to each other, which gives me a little bit of excitement. In fact, a lot of excitement as a data scientist that, wow, my predictions are almost very close to the actual. That means the model's working. That's absolutely brilliant. And that's what I want to do. So let's really dive into that accuracy, because a model is not a model if I can't deploy it and if it's not accurate. It might as well just sit down and look great on paper. So I have a transportation network, right? I look at a hierarchy in that red box. I have a state example for the hierarchy. We'll choose North Carolina, right? The home of where SaaS is. We'll go into the sales segment, enterprise accounts. We're looking at 2 lines, the actual shipping expense it cost from the transportation organization in the blue. The red line is the prediction from the Python Forest model. How great is this? The lines are almost on top of each other. That is absolutely beautiful. Music to a data scientist's ear. That means the predictions and the actuals are so close that it did a fantastic job of predicting what the actual shipping cost should be. So let's dive in further to that hierarchy. If we use a specific customer to really get our excitement flowing here, for enterprise accounts, let's pick a customer. Let's go to Eclipse Incorporated. Again, further support that my model is a very powerful model in terms of accuracy. That accuracy, again, was measured, remember, by the root average square error, which is just the measurement of noise where we wanted it very close to 0. Look at these lines. It's even more apparent that the predicted and actual are literally sitting on top of each other. That is a beautiful goal in predictive modeling. And it really was done in a very seamless, scalable, and automated environment, comparing 8 machine learning models. We were able to tap in to the great open source world of Python. We created the bridge to the SaaS next generation state-of-the-art data mining solution of VDMML, and we really left no stone unturned, uncovered, to help solve this critical business problem for the transportation network. So let's sum things up. What have we done? Well, we all know, as I started, the shipping organization has a very critical need to determine the causal factors for the cost of the package shipments across the transportation network. Understanding these factors really helps the company establish pricing for their customers to become more profitable. We integrated open source models within the next generation data mining machine learning environment, or SAS VDMML for short. It allowed for a very comprehensive analysis to address this critical business issue. Perhaps we can look at capturing other data that's relevant to package shipments, right? The modeling process is a life cycle. It's a livable, breathable element because it represents data, which represents essentially people that are shipping the packages or have the need. So maybe we can dissect further. Could there be other types of data streams to even make this model fit even stronger? But we already saw how strong it was. Finally, another great exercise we could think about doing, because I love doing things like this, is we could take the causal factors that we just revealed, like fuel expense, product, subproduct, etc., and inject them into a time series forecasting model. We found when you take the causal factors from a data mining exercise and use them to forecast something like the actual shipping expense, the forecast accuracy just goes so much better and so much higher. And that makes sense because I'm telling a forecast instead of just what I'm forecasting against time. Let's go throw in some extra causality, which I was revealing through the data mining exercise. So that would really create a comprehensive solution analytically to let the transportation organization really conduct a very high profile exercise to help them be as efficient and profitable as possible. I thank you very much for attending this session. It was an honor and a pleasure to present to you this critical business need and how open source and SAS VDMML can be together at last.